Hello friends, welcome to my video. In this video, we will discuss about APIs, the different types of APIs and the benefits of using them. We will dive into REST and RPC, understand how they work and explore best practices for using them. So let's get started. What is API? An API or application programming interface is a set of rules and protocols that allows different software solutions to communicate with each other. APIs define the methods and data formats that application can use to request and exchange information. They serve as intermediaries that enable interactions between different systems, services, and applications. Basically, there are four types of APIs: REST, Representational State Transfer; RPC, Remote Procedure Call; SOAP, Simple Object Access Protocol; and GraphQL. So in this video, we will discuss about the first two, that is REST and RPC. Benefits of using API. Interoperability. APIs allows different software systems to work together seamlessly. Efficiency. They enable developers to reuse existing functionalities without having to write code from scratch. Scalability. API can help scale services by decoupling the front end and back end. Innovation. By exposing certain functionalities, APIs enable third-party developers to create new applications and services. Now, examples of API. We will discuss about commonly used APIs like Google Maps API offers mapping and location services, includes maps, routes, and places. Twilio API provides programmable communication tools for voice, SMS, and video. SendGrid API allows for sending emails at scale with reliable email delivery. Facebook Graph API allows developer to access data from Facebook and integrate Facebook functionality into their application. Twitter API provides access to Twitter data including tweets, user profiles, and trends. Stripe API facilitates online payment processing for businesses, handling payments, subscriptions, and billing. PayPal API allow business to process payments, refunds, manage transactions, online shopping, fundraising, and peer-to-peer payments. Google Analytics API allows access to Google Analytics data for custom reporting and analysis, tracking website traffic, analyzing user behavior, and creating custom dashboard. Now let's discuss about REST, Representational State Transfer. REST is architectural style for designing networked application. It relies on stateless client-server communication protocol, usually HTTP, and treats server objects as resource that can be created, read, updated, and deleted. Using a standard set of operation, REST is widely used for web services because of its simplicity and scalability. The key concepts of API design. Client-server architecture. This design separates the user interface from data storage and processing. Statelessness. Ensure each request from client contains all the information the server needs to fulfill that request. Do not rely on server-side sessions to store information about the client state. Cacheability. Responses from the server can be stored temporarily to improve performance and reduce load. The server can tell the client to save certain responses so it doesn't have to ask for the same data repeatedly. Layered system. The architecture is composed of hierarchical layers where each layer performs a specific function and interacts only with the adjacent layers. The system is built in layers, each with a specific role, and each layer only communicates with its neighboring layer. Benefits of REST. Scalability. the ability of the system to handle increased load by adding more resources. REST makes it easy to add more servers to handle more users or data without changing the system too much. Flexibility and modularity. The ability to develop and update parts of the system independently. You can change or upgrade one part of your system without affecting other parts. For example, you can update the payment processing part of an online store without changing the way products are displayed. Simplicity. REST uses standard HTTP methods and straightforward URLs, making it easy to understand the use. REST is simple to use because of its common web standards like URLs, methods get, post, put, patch, and delete. For example, to get the list of users, you can simply use a URL like api.example.com/users and a GET request. Performance. REST can use caching and efficient communication to improve speed and reduce server load. REST is fast because it allows saving responses for repeated requests and uses efficient communication. For example, if you repeatedly check the weather, the app can cache the latest weather data so it loads quickly without always asking the server. Now the REST API design best practices. Resource based URL. You can use nouns to represent resources such as /users or /orders. You should avoid using verbs in URL. Instead, the HTTP methods indicate the action. HTTP methods. uh, Get for retrieving the data, post for creation of new resources, put for updating existing resources, delete for removing resources. Data format. Use standard formats like JSON or XML for request and response payload. Error handling. Provide meaningful error messages and use appropriate HTTP status codes. Now let us discuss about security consideration. The first one is authentication. Authentication ensures only the authenticated user or system can access the API. There are various methods which can be used for authentication like API keys, OAuth, JWT. So API keys, a simple method for each client is given a unique key that must be included in each request. OAuth, a more secure and flexible method that allows users to authorize third-party applications to access their data without share their credentials. For example, Google and Facebook. We can use OAuth to log in from Google or Facebook or Twitter into our system. Next is JSON Web Tokens, JWT. Tokens that are used to securely transmit information between parties and are often used for stateless authentication. And always use HTTPS to protect authentication credentials. Avoid embedding credentials directly in code, storing them insecurely. Next is authorization. And authorization ensure that the authenticated user have permission to perform specific action or access certain resources. For example, we have a various level of users like admin, then we have customer care service, and we have users and managers. So for that purpose we can use authorization. So there are two methods which can be used. One is RBAC, second is ABAC. RBAC is role based access control. Permission are assigned to roles and users are assigned roles. So each user will have role and can access the authorization using that role. Next is attribute based access control, ABAC. Access is granted based on attributes. For example, user role, resource type, and time of access. Next is input validation. Input validation is required to protect the API from malicious inputs that can lead to security vulnerabilities such as SQL injection, cross-site scripting, and buffer overflow attacks. In order to protect perform input validation, we can remove or encode potentially harmful characters from user inputs. Validate the input. Ensure that the input data conforms to expected format types and ranges. Rate limiting. Prevent abuse of API by limiting the number of requests a client can make within a specific period. Like IP-based rate limiting. Restrict the number of requests from single IP address. User-based rate limiting. Restrict based on user credentials or API keys. Use quotas and burst limits to handle short-term spikes in traffic. Incorporating these security considerations, authentication, authorization, input validation, and rate limiting into your API design. Ensure that your API is protected from unauthorized access and malicious activities. These measures help maintain integrity, confidentiality, availability of your API, providing secure experience of your users and client. Now you can see for architecture block diagram for the REST API, and here we have client side and client side or the front end and the back end. So in the back end we have implemented the API. So the client side can send the request. It will pass through all the logic implementation which a developer has to write for authentication, rate limit, business logic, analytics. This pass the request to data service and then fetch the data from database, get the response and pass it to the front end or your client. So this is just the basic diagram to understand the REST API, how it works. Here is the example of request and response from the API. So first one is to post the request. The endpoint is /API/product. URL can be your domain, then /API/products. Content type is application/JSON. Authorization is bearer, and then your token. It can be your JWT token. You have to pass the values like your name, description, price, category, stock, and this will create a resource. Next is get product details. So method is get, endpoint is /API/product/ID. We are trying to fetch the product details based on its IP. URL is your domain name, then API products, then the product ID. Authorization is your bearer token. So this will provide us a JSON response with all the data requested. Here you see the HTTP methods and the status code which are available for our REST API implementation. We have already discussed about the HTTP methods get, post, put, patch, delete, and the status code. These are some commonly used status codes. Now next is RPC, remote procedure call. What is RPC? RPC is the ability to client application to execute the subroutine or the function over server. RPC is a protocol that allows a program to request a service from a program located on another computer in a network, as if it were a local call. It abstracts network communication, making it look like a normal function call to the developer. The remote method invocation looks like calling a normal local method in terms of the developer code. To a developer of the client application, a method executed locally or remotely looks the same. RPC frameworks support multiple programming languages like Java, C#, Python, PHP, etc. Application written in different programming languages can talk to each other using RPC. Benefits of RPC: simplicity. RPC makes distributed computing straightforward by allowing remote methods to be called as if they were local methods. Language independence. Many RPC frameworks support multiple programming languages, allowing diverse systems to interoperate. Abstraction. It abstracts the complexity of network communication, making it easier for developers to implement distributed systems. Efficiency. RPC can be more efficient than other methods of inter-process communication because it can be optimized for specific communication patterns of the application. Now, RPC has three major components. First is client stub, network communication, server stub. Client stub, the client application has a local proxy, also known as stub for remote method. The stub takes care of marshalling the method call parameter into a request message that can be sent over the network. Here you can see the client stub and the server stub. Marshalling means serialization, data serialization, and unmarshalling means data deserialization. So network communication, the client stub send the message request over the network to the server. The communication can occur over various protocols such as TCP/IP. On the server side, a corresponding server stub receives the request message, unmarshals the parameter, and invokes the actual remote method. The server method is executed and the result is sent back to the client via the server stub, which marshals the result into response message. The client stub receives the message, unmarshals the result, and passes it to the client application, making it appear as if results were returned from local method call. Now, when to use RPC? RPC is a perfect choice for API provided to different company instead of an end user app or web page. Communication between different components within a large system. Abstracting away the network communication, focusing only on the actions of the client wants to perform. Features of RPC. RPC revolves around the actions and less around data resources. This means that the primary focus is on performing operations or invoking methods rather than manipulating resources or entities. In RPC, every action is a new method with different name and signature. This clear distinction ensures that each operation is uniquely identifiable and callable. Method have distinct signatures specifying the method name, parameters, and return type, which helps in defining clear and unambiguous interfaces. We can define many methods actions without limitations. This allows for a highly flexible and scalable system where the new actions can be easily added as needed. Now, security. RPC system can implement security measures to authenticate clients and authorize their actions, ensuring that only legitimate requests are processed. Data transmitted over the network can be encrypted to protect against eavesdropping and tampering. RPC provides a robust framework for building distributed system with a focus on performing specific actions through method calls. It's a action-oriented architecture, flexibility in defining methods, and abstractions of network communication, making it a powerful tool for developers. Additionally, features like language independence, error handling, and security further enhance its utility and ability in diverse scenarios. So here you see how RPC work. We have client and server stubs, and we have interface description language. Now the client stub is calling the function balance request with the parameter account ID, and server stub will process the request and provide the balance as the response. So this is the request, RPC request for the function balance request account ID, and here is the response from the server. Now, differences between REST and RPC. So REST focuses on resources and RPC focuses on actions and methods. Endpoint structure. In REST, endpoints represent resources like /user/orders, and in RPC, endpoints represents functions or methods. HTTP methods. In REST, we have standard HTTP methods like get, post, put, delete, and in RPC, typically uses a single HTTP method, often post for all calls specifying the action within the request body. Data format. REST uses standard formats like JSON or XML. RPC uses specific formats like JSON-RPC, XML-RPC, or protocol buffers. State management. Both can be stateless, but REST emphasizes statelessness more strictly. Now, choosing between REST and RPC depends on specific requirements of your application. REST is ideal for resource-oriented services and is widely used for web services and public APIs due to its simplicity and use of standard HTTP methods. RPC is suitable for action-oriented services and scenarios where performance and direct method invocations are critical, such as internal microservices, communication, or complex operations that require explicit parameters. Understanding these differences helps in making informed decision based on the architecture and design goals of your application. So this is all about the API design and REST and RPC. In the next video, I will come up with the remaining two API design methods like GraphQL and SOAP. Thank you for watching this video. I hope you found it helpful. Please don't forget to subscribe to my channel and like this video. See you in the next one. Thank you.